In the second part of the manufacture, we will see joint fixturing and adhesive hardening.
So let's see now the second part of the manufacture. We need to see joint assembly and fixturing, hardening and finishing. Regarding the joint assembly and fixturing, that's a very important part. Obviously, we need to join the two substrates together. We need to make sure that the surfaces are well in contact. We need to guarantee the adhesive thickness, a good wetting, and also avoid the presence of voids and porosity. This is especially important for the adhesives that cure by condensation. To maintain the substrates in position, we have several techniques. We can use molds. This is more in laboratory conditions, such as this one for single lap joints, or this one for butt joints. When we assemble the two substrates, there is also a way to avoid air entrapment. If you do something like that, you tend to entrap the air. It's advised to do something like that by rotation so that the air can escape. That's what is represented exactly in this scheme. About the adhesive thickness, that's a very important parameter to control because this will have a big impact in the final joint strength, so we should control this very, very precisely. There are several ways to do it. One way is to use microspheres, such as the scheme indicated here. These are the microspheres. We can mix this into the adhesive. Some adhesives, it's already pre-mixed. We call it also ballottini, these glass spheres. Shims also can be used, such as indicated in this scheme. So you have the joint here, and this part here, this is a shim, and this part is the other shim. And the thickness of the shim is equal to the thickness of the substrate plus the thickness of the adhesive. You can even use shims with a shape that can give you the final shape of the spew fillet. This also has an effect in the final joint strength. Another way to control the thickness is to use thin wires. Here in this figure it's exaggerated, the thickness of the wire. Generally you don't even see it. This is another good way to control the adhesive thickness. To apply pressure, you can use weights. You can use also something more control, like a press, like indicated here. So you put your mold in here and then you apply pressure in the press. Device that is very common for composite materials, it's autoclave, and you can also use it in the context of adhesive joints. This is specially indicated for joints where you have an adhesive film. It controls very well the pressure, which is also important to avoid air entrapment. In industrial situations, many times clamps are used, such as indicated here. This is in the automotive industry for a particular component, but aeronautical, aerospace, it's also common to use clamps. And then comes the hardening. You already know that for structural adhesives, chemical reaction is the main way to harden the adhesive, but you can also have loss of solvent and hardening from the melt. About the adhesives that cure by chemical reaction, there are several points to bear in mind. For example, cure is accelerated with temperature, which is nice. For example, you might have a two-component epoxy adhesive that cures at ambient temperature, but it would take 24 hours typically. If you increase the temperature to say something 120 degrees, then the time to cure would be much reduced. Then you have the aromatic adhesive like bismaleimide that take higher temperature to cure. Typically you would do it in 2 steps. First a cure at typically 175, and then a post-cure. You remove the joint from the mold, and a post to avoid too much residual stresses, and then post-cure at higher temperature. The TG is increased when you increase the cure temperature, but we shouldn't also abuse too much and use too high temperature, because then we start to degrade the adhesive. About the temperature, there are several devices to apply the temperature. There is ovens, there is hot press, but it's very important to control the temperature of the adhesive. Don't use the temperature of the press or the oven. You will have wrong results. You should have a thermocouple next to the adhesive, and only when the adhesive reaches the cure temperature, then you start to count the time of curing. Sometimes you are interested in heating only a local place of the joint. This makes sense more in industrial applications with big components. There are several ways to apply a local heating. You can use induction heating, where you use coils to induce a current in the joint, and then by Joule effect you have a heating of the joint, but this works only with conductive substrates like metal. In case of composite it's harder, but you can load the adhesive with metallic particles and then it works. For cases where you don't have conductive materials, you can use dielectric heating, microwave heating, for example, to join plastic materials. That works. And finally, you can also use a heat blanket. This is very common in repairs in the aeronautical industry, as indicated here. So imagine you have a hole, you put some laminates, and on top you put the blanket that would heat only locally the joint to be repaired. So that concludes the manufacturing part.